For this problem, we're going to look at parametric equations corresponding to these four shapes. The first one, line segment. We actually have a formula for this, that if I have a line segment connecting the point AB to the point CD, then the line segment between them is going to have the parametric equation x of t is equal to a plus c minus a times t, and y of t will be equal to b plus d minus b times t. And it's a line segment, so I want the values of t to vary between 0 and 1. And so from that, I can write down immediately the parametric equation here. So x will be equal to, or x of t is equal to a, which is 5, plus c minus a, so 1 minus 5, times t, so 5 minus 4t. And y of t will be equal to 2, plus negative 3 minus 2 times t, so 2 minus 5t. And then the t values will vary between 0 and 1. As a quick check, if I plug in t equals 0, then those go away and I get 5, 2, which is exactly what I want. If t is equal to 1, then 5 minus 4 is 1, and 2 minus 5 is negative 3. So 1, negative 3, which is exactly where I wanted to end up. Okay, so that's number 1. Number 2, we are given this function, y is equal to 2x squared minus x minus 6. And we're graphing between negative 1, 5 and 2, 0. So if I have any function, let alone a parabola, but if I have any function, then the parameterization that I will use is x of t is equal to t, and y of t is going to be equal to f of t. And my f of t this time is 2t squared minus t minus 6. So there's my parameterization. X is equal to t, y is equal to 2t squared minus t minus 6, the exact same thing that I see here. And the values of t, well, the x-coordinates go from negative 1 to 2. And so that'll be the range for t. T will range between negative 1 and 2. And so that will be the graph of this one. Okay, next we have a couple of circle problems. And we have the circle with center at 2, negative 4 and radius 3 drawn counterclockwise. And so we have a formula for this one. If I have a circle of any type, here's my center at HK, and my radius is R, and I draw the circle here. Very poorly draw the circle, but draw the circle here. Then the formula is going to be h of t is equal to h plus r times the cosine of t, and y of t will be equal to k plus r times the sine of t. And I need to take one revolution of this, so t between 0 and 2 pi will do. And so for this problem, we would have that x of t is equal to 2 plus 3 times the cosine of t, and y of t will be equal to negative 4 plus 3 times the sine of t, and t must range between 0 and 2 pi. Okay, now number 4 is going to look an awful lot like number 3, except for one little catch. This parameterization automatically draws the arc in a counterclockwise direction. This time, however, we want a clockwise direction, going the other direction. Okay, so let's start writing here. So what I'm going to write here is going to be slightly incorrect, but I'll fix it later. Negative 1 plus 4 times the cosine of t, and y of t is equal to negative 5 plus 4 times the sine of t. Now, that would be correct if it was going counterclockwise. However, I want it going the other direction, going clockwise. And so to make time go the other direction, I replace the t by negative t. And that'll make the time go backwards, basically, so that it goes in the other direction. Okay, now using a trig identity, we have -4 plus 4 times the cosine of t. Cosine is an even function, so the negative goes away. But here, sine is an odd function, and so the minus comes out. -5 minus 4 times the sine of t. And again, t will range between 0 and 2 pi for 1 revolution of the circle. Okay, so that's the handling of these 4 figures.